Right, this is question 4 from test 4. Straight away, I know that it's not A and it's not C, because A and C are both quadratic graphs, and we know quadratic graphs look like this, and the line, sorry, they should be wiggly, the lines just keep going up and up and up and up and up forever and ever and ever, whereas these ones kind of look like that, but then are curving out like this, and this, and quadratics don't do that. It's not B either, because B is a cubic, and we've said before that cubics look like this or this, and it's not doing either of those things. So that leaves us with only two choices, D or E. And there are two ways we can work out whether it's D or E. One of the ways is harder to understand than the other. But the first way is to look at the bottom of this fraction. Now, we've said before that fractions can't have a bottom of 0. Okay, the bottom of a fraction can't be 0, because if the bottom's 0, anything divided by 0 gives us an answer of infinity, or the calculator would say it's undefined. And when that happens, you get graphs that like zoom off to the top but never actually cross over a number, and it's called an asymptote. Now, on D would have an asymptote, because the bottom of this fraction, there is a number that exists for the bottom of the fraction to be 0, and it's when x squared is equal to 0.5, or x is equal to the square root of 0.5. So D would have an asymptote, which means it can't be D, because our graph doesn't have an asymptote. It doesn't have one of those curves like this, where it's going up and up and up and up and up, but not actually reaching a number. Which tells me it has to be E, just by a process of elimination. We can check if it's E by looking at some coordinates. Now, if we, for example, look at this coordinate here, this is 2, 0. This coordinate here. So that means that when we substitute 2 into this equation, we should get 0 out of the equation. So for E at x equals 2, y should equal 0, or f of x should equal 0. So do we get 0? That's going to be 2 times 2 take away 2 times 2 plus 1 divided by 2 squared plus 1. We've got a 0 on the top here. So on the top we've got 2 times 0 times 3 divided by 5. When you times something by 0, you get 0. So we've got 0 divided by 5 here, and 0 divided by 5 is 0. So that works. That does give us 0. If we were to check minus 1 as well, it would give us the same result, because we'd have a minus 1 plus 1 in this bracket. So this time this bit would be 0, the end bit, the end part of the bracket would be 0. And we'd have other numbers here, and we wouldn't have 0 on the bottom. So that's okay too. So both of these points suggest that we have this as the correct graph. Okay, and question 5 is another differentiation question. They're saying a derivative is the differentiation, and we talked previously about differentiating e to the 3x, or e to the something x. E to the just x on its own, when you differentiate that, it just keeps turning into e to the x, e to the x, e to the x every time. So e to the kx, if we did this k times, that means so 3 times or 4 times or 5 times or however many times, k times, e to the kx would be, f to the kx would be just e to the x again. The 3 makes us have to use the chain rule that we've talked about before. So if we have a 3 in here now, we use the chain rule, which says we pretend this is an x and differentiate. So initially it would just be e to the 3x, but then we have to times by what we get when we differentiate this thing here that we pretended was an x. Now when you differentiate something x, anything x, it turns into just that anything. It turns into just whatever this number is in front of the x. So here it will times by just 3. So the first derivative, the first time we differentiate e to the 3x, we get 3e to the 3x. The second time, we're going to have a 3 already there, but then this bit is just going to differentiate again to what we did before. So this time, the differential is going to be 3e to the 3x, but now times by 3 again. That will be for the second derivative, which is going to be 3 squared e to the 3x. The next time we differentiate e to the f of 3x, or f triple dash x, is going to be, this is just going to be 3 squared. I'll leave that as it is. This is going to differentiate again to 3e to the 3x, but we've already got that 3 squared there. That's a 3. So that will become 3 cubed e to the 3x. And hopefully you can see that there's a pattern emerging. It was a 3 squared for the second derivative. It was a 3 to the power of 1 for the first derivative. It's going to be 3 to the power of 4 for the fourth derivative, and it's going to be 3 to the power of k e to the 3x for the kth derivative. So that is B.